For today's topic, we have solving problems using Venn diagrams. Venn diagrams are useful in showing set operations. Now let's solve problems using Venn diagrams. The Venn diagram shows students' involvement in two sports. So the two sets will be represented by S and B. We have swimming and badminton. If 100 students were surveyed, how many students were into swimming but not badminton? So this is the Venn diagram that refers to the first question. The set only includes those in S but not in B. So the number of elements of the intersection of set S and B prime is equal to 20. Next, into both swimming and badminton. The set is the intersection of S and B. Therefore, the number of elements of the intersection of S and B is 15. Next, into either swimming or badminton. The set is the union of S and B, so both sets S and B are shaded. Therefore, the number of elements of S union B is just the sum of all the numbers in the shaded region, and that is 20 plus 15 plus 35 is equal to 70. Next, neither into swimming nor badminton. So the set does not include elements that are in S or in B. So that is the union of S and B. Since the number of elements of S union B is equal to 70, and the universal set is equal to 100, then the number of elements of S union B prime is equal to 100 minus 70, and that is 30. Next example, "60 people are asked about the pets they keep at home. The Venn diagram shows the results. So let set B the set of people who have birds, set C is the set of people who have cats, and set D is the set of people who have dogs." Refer to the Venn diagram, and it shows the distribution of the number of pets in every region. So, how many people have birds? This refers to all the people that are in B. So the number of elements in set B is the sum of 3, 1, 7, and that is equal to 11. Next, how many people have birds and cats? Again, and suggest intersection. So this is the intersection of B and C. So the number of elements of the intersection of B and C is equal to 1. For letter C, how many people have birds or dogs? So or suggest union. So this is the union of birds and dogs, or sets D and D. So the number of elements of the union of B and D is the sum of the numbers in these regions. And that is 3 plus 7 plus 1 plus 10 plus 19 is equal to 40. Next, how many people have cats and dogs but not birds? So this refers to the intersection of cats and dogs. So this is the region or sets, the intersection of sets D and D, but excluding B. So the number of elements of the intersection of B prime and the intersection of set C and D is only 10. E, how many people have birds or cats but not dogs? This refers to the union of birds and cats, but excluding dogs. So the number of elements of the intersection of D prime, so not B, and the union of set B and C, so this is the union of set B and C, is equal to 3 plus 6, and that is 9. Next, how many people have all three? Meaning to say people with bird, cat, dog as pet at home. So this is the intersection of B, C, and D. So the number of elements of the intersection of B, C, and D is 1. Letter G, how many people have neither one of the three? This does not include any B, C, or D. So first we need to get the union of B, C, and D, and that is equal to 46. Subtract 46 from the total number of people to get those people without a bird, a cat, or a dog. So the number of elements of the complement of the union of B, C, and D denoted by B union C union D prime is equal to 60 minus 46 equals 14. Now let's try this. Suppose the universal set is the set of all students. F represents the students who like fruits, and B represents the students who like vegetables. The regions of the Venn diagrams of sets F and B are labeled A, B, C, D. Which region or regions would contain students who like fruits? So this is the region of set F. So we have A and B, or B and A. Next, who like fruits and vegetables? So when we say and, that is the intersection of fruits and vegetables. So we have A. Next, like fruits or vegetables. So that is the union of fruits and vegetables. So we have to write all in this region, so or include all in this region. So we have A, B, and C. Next, who do not like vegetables? So we have B and D. Do not like fruits or vegetables. So that is not the union of F and B. So excluding this region. So we only have D. Last, do not like fruits and vegetables. So that when we say and, that is the intersection. So meaning to say excluding this region. So we have D, B, and C. Okay, for your study tip, Venn diagrams are named after the English logician John Venn. So that's all for today's topic. Again, I hope you've learned from solving problems using Venn diagram or by Venn diagrams. Thank you and God bless.